Hi, in this video I want to introduce PyTorch training loop. PyTorch is an open source ML and deep learning framework primarily used for building and training neural networks. It's the most widely used framework in AI research and production. By the end of this video, you'll understand the different steps required to train a small neural network in PyTorch. Here's a rough outline of the topics we're going to dive into. We'll talk about PyTorch first, highlighting key concepts. Then we'll design a small neural network using nn.Module class. We'll talk about datasets and data loaders, and finally conclude with an end-to-end training loop. Core ideas behind PyTorch. First, it's a tensor-based computation. PyTorch uses tensors, which are multi-dimensional arrays similar to numpy but optimized for GPUs. Automatic differentiation, or autograd. PyTorch automatically computes gradients needed for training neural networks using backpropagation. Deep learning library. PyTorch has a number of useful building blocks that utilize tensors and automatic differentiation. Dynamic computation graphs. Every neural network can be represented as a computational graph where nodes are operations or variables and edges represent flow of data between operations. Dynamic graphs are computed on the fly at runtime, in contrast to static graphs that are built first and then executed. Dynamic graphs offer more flexibility, while static graphs have more optimization opportunities. Finally, you want to utilize your GPUs for neural net training. PyTorch supports both GPU and CPU training. Let's look at one of the modules we're going to use today, the nn.Module. This module is used as a base class to define neural networks and model components. At a high level, it stores learnable parameters, weights and biases, organizes layers into a model hierarchy, defines the forward computation, and integrates with autograd, optimizers, saving, loading, and device computation. On the right, we see a simple multi-layer perceptron MLP implemented in PyTorch using this module. As you can see, first we subclass the nn module, and in the init constructor we define the layers parameterized by the num inputs and num outputs parameters. Also, we define the forward pass, how the input propagates through our network. In this case, self.layers is built with the help of nn.sequential, which means that our input goes sequentially through these layers. Finally, we return logits, which are unnormalized model outputs before they get converted to probabilities. In this next section, we're going to look at datasets and data loaders. Datasets define what the data is, and data loaders define how the data is delivered to the model. Notice in the simple dataset class on the right, we have getItem function that returns one training example and len function that returns the size of the dataset. Data loaders wraps a dataset and provides batching, shuffling, parallel loading, and iteration support. For example, shuffling randomizes the order of training points in each epoch, and num-worker loads data in parallel processes. Let's look at a simple training loop. Each epoch is one full pass through the training dataset. For each epoch, we set the model in training mode. Some layers behave differently during training versus inference, for example, dropout and batch norm. We iterate our batches from the data loader we saw in the previous slide. We move tensors to devices, this could be GPU or CPU. We turn neural network compute forward pass of the input batch and get logits at the output, which are normalized prediction scores. We compute the cross entropy loss. We zero the gradients because in PyTorch gradients accumulate by default. We then do a backward propagation pass by calling loss.backwards, and finally we update the network parameters with optimizer.step, where common optimizers include AtomW, SGD, and RMSProp. Now let's take a look at a PyTorch notebook. The notebook pulls together the different code pieces that we already covered into a complete training loop. We start by importing PyTorch and defining our model. We're a subclass nn.Module base class. We have num inputs and num outputs parameters. The model consists of 5 layers with a linear layer followed by ReLU nonlinearity. We can display the number of trainable parameters as well as the device. I'm running this on my laptop, so I'm using a CPU. We can see the layer by layer output of the model. Next, we define our train and test datasets and configure the train and test data loaders. We choose Atom W as our optimizer and set the number of epochs and execute our training loop. Finally, we can compute the accuracy, evaluating the model on the test set. I hope you enjoyed this video. PyTorch is such an essential library for deep learning research and development. It's important to understand the foundations and building blocks behind this library. Let me know what model you're going to train next in the comments below, and don't forget to hit like and subscribe. Thanks for watching.